Hello and welcome everybody. In today's webinar, we're going to be talking about creating advanced question types in Maple TA and Möbius. So there have been a part 1 and a part 2 in this series covering some of the basics of question creation in Maple TA and Möbius. So today we're going to be looking at some of the more powerful tools that we have available to us in these systems. So we're going to start today by looking at Maple graded questions. So here I'm just logged into my content repository in Maple TA. If you're using Möbius, that will look roughly the same, although you'll have some extra options. But we'll have the same functionality as it applies to these particular questions. So I want to start with a Maple graded question that I've already authored, and I'm going to preview that and talk a little bit about that question. So here we're asking the student for any equation of a line that passes through some randomly chosen point. In this case, it's the point 3, 9. And we're asking the students to answer this question as a Maple graded question. So typically, if I wanted to ask something open-ended like this in most systems, I'd be restricted to probably a multiple choice question because we need to be able to assess the students in a way that is giving them freedom in answering this type of question, which we really can't do in a lot of systems. So with Maple TA and with Möbius, we can interpret the student's response mathematically and really perform the same assessment that we would as an instructor. So here I've got my equation editor for student entry, and I can put in one of really any of the infinitely many correct answers to this question. And I'll click how did I do so I can check my work right away. And we'll see here that with 3x I was graded correctly. Here in the feedback, I gave a couple of examples of other responses that would have been graded as correct, but really any valid line in X and Y that passes through that point would have been graded correct in this case. And so we can check that things that are not linear, that also pass through that point, are going to be graded as incorrect. And then we'll talk a little bit about how we actually create this sort of question. So I'm going to close this, and we'll open up this question for editing in the question designer. And so I won't spend a lot of time focusing on the algorithm itself here, other than to say I've set this question up that X and Y vary. So we've tried to handle the question in generality. So if I look at my algorithm, I'm just randomizing the X and the Y points. Although in this particular case, if you look closely, I've actually removed the randomization so that I had one particular example to work with for the demo. But then I'm also generating some output for the feedback here in my algorithm. But otherwise, it's a fairly straightforward algorithm. Really, the magic is happening in the Maple graded response area and in the grading code. So here I'm going to open up my response area, and so we've set it to be Maple graded. And if we focus in on some of the settings we've made before we look at the grading code, we've set expression type to Maple syntax. So this is going to allow students to enter responses that are richer mathematically than with the formula syntax option. So for example, as it applies here, this allows us to enter equations as correct answers rather than simply expressions. It would let us input matrices and multi-letter variable names, Greek letters, that sort of thing with the Maple syntax option. And then we've set it to symbolic entry so that students have the equation editor. In this particular case, it really doesn't matter, that whatever makes the most sense for you and for your students is valid here. And then if we look up here at the correct answer area, where we would typically define the correct answer. Here I've actually just written something out in text because there isn't one absolutely correct answer. There really are an infinite number of correct answers. So I've just made that statement here. Now, typically in a Maple graded question, we would see default grading code that looks sort of like this that I'm entering right now below. Would be eval answer response minus answer equals 0. And so really all that would be doing is taking what was defined in this answer region, subtracting it from the student's response, and checking to see whether that equals 0 and returning a Boolean, whether 0 if they are not equal and 1 if they are equal, and that would be the grade the student gets. But we've removed that and we have some different grading code here. If we look carefully, I don't refer to $answer, and that's because I've defined it as the string that really isn't relevant to grading the student's response. So really, we can always write an algorithm that doesn't refer to what's in the answer box here. But obviously, we want to use the student's response, which is $response in all caps. And so really what we want to do to check whether the student is correct is to check if the student has entered a linear function, or sorry, a linear equation, and whether that point happens to pass through that equation, or so that we can sub in the values of the point into the equation and check for equality. So really we've done that in just a couple of steps. So the first thing we've done here is I've taken the student's response and I'm just collecting all of the terms onto one side into one expression. So I'm taking the left-hand side of their input and subtracting the right-hand side of their input just to make an expression that's equal to 0. Just makes my life a little bit simpler when we're evaluating what they've entered. Then the next line here is really we're just checking, is that expression linear? So we're using the type function in Maple, and we're checking whether the type of this solved expression is linear. So that's doing our check to make sure that it is in fact linear and it's not a quadratic, or it's not any other sort of form of function. Then we're checking to see if the left and the right hand sides are equal. So basically we're using the subs command in Maple. We're subbing in the point for x and y, and we're putting those into the student's response and checking to see if the left hand side equals the right hand side. And then finally we're just saying we're just taking those two Boolean answers expressions that we created and verifying that they're both true at the same time, and if so, we're returning 1. If not, we're returning 0. So for each of these intermediate expressions, we've terminated them with a colon, and the final one with a semicolon. That will just ensure that this is what gets picked up as the student's grade. And so there, just in 4 lines, we've basically done what we would do as an instructor to grade the student, just with some simple Maple calls. And that really allows us to test the students in a more meaningful way. They can be creative in their the way they answer the question. We don't have to tell them to solve for y or any other sort of formatting constraint. So obviously in your particular setting, having that much freedom may or may not be valuable. You might want to put some restrictions on it, but we can follow roughly the same procedure and put another check in here to look at the format of the student's response as well. You will also notice I've got some plotting code here. So in the plotting code section, I just have a little bit of Maple plotting code, which I won't go into in any depth, but I just wanted to point it out because a lot of people don't realize this option is here. This gives the student the ability to actually plot their input. So if I go back to my preview, and once again enter an expression and hit the little plot icon here, then we'll generate a plot of using that plot statement. So in this case, I'm just doing an implicit plot of the student's function, and I'm plotting the particular point in the randomization. So we may or may not want to give students the option to do that. For example, here this lets them check whether their answer is right, but we may also find that to be a value for our particular needs. All right, so jumping now to math app questions. We're just going to put together a very simple math app in Maple. So in Maple here, I'm going to go to the embedded component section, and I just want to create a simple plot that I'm going to control with a slider. So I'm going to add a plot component into my math app, and I'm going to add a slider. And I'm going to right click on the slider and change the component properties. So knowing ahead of time what I want to create kind of makes this simpler. If you aren't sure what you're actually creating, then this might take you a little bit longer. But basically we're just going to set some constraints on the slider, what the lowest and highest value are, whether we're going to show labels. And then I'm going to right click on it again, and I'm going to create a change action. So what this means is that as that particular component is changed by somebody's input, this is going to define what actually happens in the worksheet. So I'm just going to paste in some code that I have already, which is basically saying to do, so this is using the document tools language in Maple. I'm going to make the plot component equal to the output of this plot statement using the value of the slider. So if I save that, then we can see that as I adjust the slider, that we will update the plot appropriately. And then we're also going to define some grading code, because we're going to ask the students a question with this particular math app. We're going to ask them to basically plot a particular quadratic equation, and we're going to define how to grade that here in the startup code. So in order to grade the student in our worksheet, we define a module called actions, and it has to export a function or a procedure called grade, and that grading procedure just needs to return a value between 0 and 1. So here the right answer is going to be defined if they happen to have placed the slider into the position -2, then we're going to return a grade of 1, otherwise we're going to return a grade of 0. So with just a couple of modifications, we've just set some grading code, and we've set the change action on one of the components. We basically have a gradable math app ready for our student. So we can save this somewhere and upload it into our class, or we can also use the connection to our Maple TA or Möbius server directly in Maple. So if you come to the Maple Cloud palette in Maple and go to more actions on the bottom left here, we can add a Maple TA or Möbius account. So we put in our username, password, and the URL of that particular server. Then we can connect to all of our classes on that server. So for example, I'm loaded into the creating questions in Maple TA and Möbius class, and I can save my worksheet directly into that class. So if I click on this upload button here and give my worksheet a name, then that will be sent up to the server, and then I can access it on the server. So now if I come back to my Maple TA instance and I look at my view files, I'll see that quadratic 2 that I just uploaded is sitting there in my file manager. And so we want to make that into a question. So we're going to create a new question, and I'm going to call this my quadratic math app. and we'll insert the response area, and we'll select Math App, and then I'll choose the worksheet that we just uploaded. And we won't change anything else here. We're using a grading algorithm that we defined in our Math App, and that's the default setting. I could also define the algorithm right here for grading. I could also set it to be manually graded, which means it would work like an essay response area where I need to go into the gradebook and assign a grade. Or I can set it to not be graded at all, in which case it's just for the students to explore the concept. So I'll click OK now, and we can preview our question. And so the student can now interact with the slider, and we set the correct answer to be when it's in the position -2. So we can check to see that it's graded correctly, and that anywhere else will give us an answer of 0, or sorry, a grade of 0. And obviously we'd want to add some text to the question to tell the student what they're actually intended to do here, but that's the basic part of getting that set up. And so we can also randomize the problem as well. So if we have variables that are defined in our worksheet, we can connect those variables to our MapleTA randomization by using these initialization parameters. So if I had a variable called x, y, z in the worksheet, and I wanted it to be equal to some MapleTA or Möbius variable $A, then I can simply put that expression into initialization parameters, and that randomization will come through into the worksheet. And finally, I want to talk a little bit about HTML questions. So Maple graded question gives us a great way to create response areas or questions that are mathematically meaningful, but that are things that aren't directly supported by the response areas in MapleTA and Möbius. So it may not simply be a numeric response or a true or false question, but it's something like what we just created, where we want them to really interact with some mathematical object or many mathematical objects potentially, and assess them based on that interaction. And so the Maple language and the Maple document system provides a good way to generate that sort of assessment without needing to know a lot of general purpose programming skills. However, if we want to go a step further and create things that maybe aren't mathematically oriented or not in the same way, things that aren't supported in Maple itself, then we can go to the HTML question. And so that, again, lets us create something that goes beyond what MapleTA and Möbius do with their built-in response areas, and gives us a lot of flexibility in how we implement them. So I've got a very simple response area, and this is definitely something you wouldn't give to a student. Really, all I've done is I've made a checkbox, and if I check the box, I'm going to give the student 100%. If I don't check the box, I'm going to give them 0. But the point is that this is just some arbitrary HTML and some JavaScript used to check that creates a question that isn't natively in the system. So if we open this up, and I'm going to open up my HTML response area, what I've created here is all defined in this response area. So the question HTML is basically just an input, so an HTML input, just using standard HTML. I've given it an ID and a name so that I can refer to it. I've got a little bit of CSS or cascading style sheets just to make that input bigger than the default that you'd get in your browser. And then I have a little bit of JavaScript code. And so there's three things that our JavaScript needs to do. It needs to initialize the problem. It needs to be able to set the state of the response area for feedback, and it needs to be able to get the student's input out of the response area and send it to the system to be graded. And once we do that, then it comes to our Maple grading code, which actually assigns a grade, just like any of our other Maple grading algorithms. And so here I'm basically using the same one that we use in a default Maple response area. I'm checking is the dollar sign answer equal to dollar sign response. And so here, once again, answer is defined right there, and response is what I'm returning from this getResponse function. So in the case of this simple input box, getResponse is really just using some JavaScript to get whether or not this checkbox was actually checked. If it's checked, I'm returning true. If it's not checked, I'm returning false. And then we're assigning a grade appropriately. And then in the set feedback section, all we're doing is we're saying if the correct answer is true, and we're looking at showing the student what the correct answer is, then we're going to check that box programmatically when the question's initialized. Or if we're looking at the student's response in the grade book, then we'll do the same if they've actually checked the box when they did their input. And then in initialize, the only other thing we're doing is if we're looking at the feedback, so we're just rendering a static version of that question for the student to see what they did, or for the instructor to see what the student did. Then this variable interactive mode is false, which means that we're rendering this in a way that the student or instructor can't interact with it. They can't change anything. So we're just disabling that checkbox in that case so that it can't be changed. So really just three things. We need to have some code that may do something to initialize that response area. We have some code that gets the state of it that we're going to send to the grading code. And then we have some code that initializes it into a particular state in the feedback section. And then a little bit of Maple grading code to actually evaluate it. So this is a very, very simple example, just a checkbox. And if we look into the grading here, we'll see that it's disabled here in the feedback, so we can't change it. But it means that we can go well beyond that. So for example, we might create something like this. So this is a drag and drop response area where we've got some labels that we're putting onto a particular diagram, and so we can place those here, and we can click grade, and here we'll see both our response and the correct response. So this is the using the setting to actually initialize the feedback, both with the student's response and the correct response. And here we're highlighting which ones the student got correct and which ones they got incorrect. Or we could do something, again, this one's another drag and drop example, but a little bit more dynamic in some sense. But again, just using the same concept here of being able to initialize, set the state, and get the state. So what goes into this sort of blank canvas is up to you. It could be something that you've written code for, like we showed in the checkbox example. It could be an existing web application that you have access to. If you can programmaticradically set the state and get the state of it, then you should be able to integrate it using the HTML response area to make it gradable within Maple TA and Möbius. All right, so that's all the time that we have, and I know that was sort of a very quick overview of three quite deep response area types. So hopefully that at least gives you a sense of what you can do and a place to get started in authoring those questions. The help section on our website goes through some more detailed examples of each of these problem types, otherwise the Maple TA and Möbius community is a good place to ask questions. Our help team is more than happy to answer questions, and I expect we'll do some more in-depth, focused webinars on the individual response area types in the near future as well.